In this video, we're going to talk about exponents. So what is an exponent? Exponent is basically repeated multiplication. Just as multiplication represents repeated addition and division represents repeated subtraction, we needed a way to represent repeated multiplication. In multiplication, we have, let's say, 2 times 4. This means that we have a group of 2, and we have 4 of those groups. That's what multiplication means. 4 groups and a group of 2. We have a group of 2, and we have 4 of those groups. An exponent represents repeated multiplication. So if we have 2 to the 4th, this represents a group of 2 multiplied by itself 4 times. So we have a group of 2, and we have 4 of those groups multiplied by itself 4 times. When we have something like this, the 2 is the base, and this is the power, or an exponent. We say this is 2 to the 4th power, or 2 with an exponent of 4, or 2 to the 4th. So when we perform the multiplication of 2 to the 4th, we get 2 times 2 is 4, times 2 again gives us 8, times 2 again gives us 16. So 16 is a numerical value of 2 to the 4th. You also need to be aware of 2 special powers that have special names. Let's say we wanted to represent the multiplication of 4 times 4. Because these 2 numbers are the same, we can represent this multiplication problem as 4 to the 2nd power. And 4 to the 2nd power, or 4 times 4, gives us 16. Now the 2nd power has a special name. It is called the square. And the reason it's called a square is because it is how you find the area of an actual square. Say we have a square, and each side of this square is 4 units long. And the way you would find the area of the square is to multiply the base times the height, which gives us 4 times 4, which is the same thing as 4 to the 2nd power. The 2nd power is called a square because whenever you multiply the same number by itself, you get the area of a square. So instead of saying 4 to the 2nd power, we can just say 4 squared. Another exponent that has a special name is called the cube. Let's say we have a problem of 5 times 5 times 5. That's 3 5s. So we can represent the multiplication of these 3 5s as 5 to the 3rd power. Now the 3 is also called a cube because a number multiplied by itself 3 times is what gives us the volume of a cube. Let's say we have a cube. And each side of this cube is 5 units long. Now to find the volume of this cube, we just have to multiply 5, the length, the width, and the height, which is 5 times 5 times 5, which gives us 125. Or we can represent this value as 5 to the 3rd power. And because multiplying a number by itself 3 times is the same thing as finding the volume of a cube, we would say that 5 to the 3rd power is 5 cubed. Now let's take a look at a special case that involves exponents. Let's say we had 5 to the 0th power. Would that mean that this equals 0 or does it mean that it equals 5? To find out why that is, let's look at powers of 10. Let's say we have 10 to the first power, which is basically 10 and not multiplied by anything, which is just 10. Then we have 10 to the second power, which is 10 times 10, giving us 100. Then we have 10 to the third power, which is 10 multiplied by itself 3 times, giving us 1000. Then we have 10 to the fourth power, that's 10 multiplied by itself 4 times, giving us 10,000. Now if we analyze the pattern in the answers we get when we multiply 10 by a power, we see that the exponent corresponds to the number of zeros we have. Here we have an exponent of 4 and we have 4 zeros. Here we have an exponent of 3 and we have 3 zeros. Yeah, exponent of 2, 2 zeros. And if we follow this pattern up, that means that 10 to the 0th power would be 1, because it has 0 zeros. Now 10 to the 0 power is 1. That's the real answer. It's not 0 and it's not 10. It is 1. And we found that 10 to the 0 power is 1 because we follow the pattern up. So 10 to the 0 power is 1. And we got this answer by following the pattern. But when we're faced with a problem like this, it's not as obvious why it's 1. Now the answer of 1 is not only true for 10 to the 0 power, but it's also true to 5 to the 0 power, and pretty much any base number that you put to the 0 power will always give you 1. You can have 4 to the 0 power, which is 1. You can have 20 to the 0 power, it's also 1. 11 to the 0 power is also 1. And to find out why this is true, we're going to have to work some problems. First, let's take a look at what happens when we're multiplying exponents. Let's say we have 5 to the second power, 5 squared, and it's multiplied by 5 cubed. Now we know what 5 to the second power means. It means 5 multiplied by 5. And we know what 5 to the third power means. It means 5 multiplied by 5 multiplied by 5. And of course, these two are multiplied together. So in total, we have 5 5s multiplied by each other. So we can say that 5 to the second power times 5 to the third power is 5 to the fifth power, because there's 5 5s multiplied together. From understanding what is happening in the background when we're multiplying numbers with exponents in them, we can create a general rule for multiplying exponents. Here we see we multiplied 5 to the third by 5 to the second power. And as you can see, all we did was basically just add the exponents, because we add up all the numbers. So as a general rule, when you multiply exponents together and the bases are the same, you can just add up the exponents, 2 plus 3, so which will give you 5 to the fifth power. When we're dividing exponents, we're basically doing the opposite. So we have 3 to the fifth power divided by 3 to the second power. And we know what 3 to the fifth power means. It means 3 multiplied by 3 by 3 by 3 by 3. 3 multiplied by itself 5 times. Now, because we have a division, we put it in fractional form. Now, 3 to the second power goes in the denominator of this division problem. So 3 to the second is just 3 times 3. when the problem is in this form, we can see that we can just cancel out the multiplication and division, leaving us with 3 times 3 times 3 in the numerator, which is basically 3 to the third power. So as a general rule, we can see that whenever we're dividing, and the bases are the same, we can just subtract the exponents. 5 minus 2 is 3, which is exactly what we got here. So it's 3 to the third power. Now let's look at what happens when we raise an exponent to an exponent. Say we have 2 to the fourth power, and that is raised to the second power. What this means is 2 multiplied by itself 4 times, and then we also have 2 of those. So we have 2 times 2 times 2 times 2. And all of these are multiplied together. And when you add up the multiplication, you have 2 to the 8th power, because there's 8 2's. So 2 to the 8th power. And as a general rule, we can see that 2 to the fourth power raised to the second power is basically like multiplying 2 times 4. So whenever we're raising an exponent to an exponent, we can just simply multiply the exponents together. 2 times 4 is 8, so it will be 2 to the 8th power. So now that we understand the rules of multiplication and division of exponents, let's work a multiplication problem that involves the exponent of 0. Let's say we have 6 to the third power, and that is multiplied by 6 to the 0th power. Now we know that when we multiply two exponents with the same base, we just add the exponents together. So 3 plus 0 gives us 3. So it's going to be 6 to the third power. As we can see here, 6 to the 0 power has to be 1. It cannot be 0, because anything multiplied by 0 would give us 0. And because this adds up to 6 to the third, this has to be 1. Now let's take a look at a problem that involves division of exponents. Let's say we have 7 to the fourth power. That is divided by 7 to the fourth power. When we draw this out, we get this problem equals 7 to the fourth power is 7 multiplied by itself 4 times. And that is divided by 7 to the fourth power. So 7 multiplied by itself 4 times. As we can see here, the numerator and the denominator is the same. And whenever we have that, that means the answer to this is 1. But we could have also used a rule for dividing exponents, which is just to subtract the exponents from each other whenever we have the same base. So 4 minus 4 is 0, which would give us 7 to the 0th power. As you can see, 7 to the 0 power equals 1.